How does one get rid of a Goomba? Presumably, you have an array list of sprites in your model. And in this list of sprites somewhere, you have a, in that list is a Goomba. Are my assumptions correct so far?
Yeah.
Okay. So how does one get rid of a Goomba? Well, okay, let me show you this cheap hack. Ha 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 ha. This will basically make the Goomba jump way off to infinity where you'll never see him again. Problem solved. Wash your hands of the problem. Never do this. This is awful, horrible code. But you know, you could, right? Okay. Better solution is every Goomba's got an update function. And in this update function, you're going to say if go right, then x plus plus, else x minus minus. And somewhere in here, if I collide with the tube, then flip my go right Boolean value. Is that about what your Goomba looks like?
Yeah.
Okay. Well, here's a possible suggestion. What if we go to our sprite class where we have this abstract bool update method, void update method, and we change that void to a bool so that now all the update methods return a Boolean value. Now I'm going to have to go to all of my update methods and make them return a Boolean value, and I'll make that Boolean value always return false. And down here in my model update method, where it looks like this, 0 I plus sprites dot size I plus plus sprite s equals sprites get I s dot update. This is about what your model update looks like, right? I would change it to say this: if sprite dot update, if this update method returns false, that means I want you to kill me. It's the kill me now, life is not worth it anymore variable. And wait, does true mean die or does false mean die? If we return false usually, then that means true means kill me now. So when I say update, if you return true, that means kill me now. And to kill it, we will say sprites.remove hi. Basically, that's how you kill a Goomba. And this will allow anything to kill itself. So even Mario could return a true, and then Mario would be removed from the list of sprites. Just make sure Mario never returns true. Just always return false, and that doesn't happen. And the issue that comes up is, what if you're using an iterator right here instead of an I? Then you make sure you call the iterator's remove method so you don't get concurrent modification exceptions. And let me point something else out. If you're using an integer to iterate over an array list, and you remove I, note that that changes the size of your array list. If the Goomba just happened to be the last thing in the list, what happens? Well, then I is incremented, and it loops around, and I is already bigger than the size of the sprites, and so it exits and nothing bad happened. We're okay because of the way this code was written. But what if right here I did something with it? I checked sprites I, or something like that. Do you see how this could potentially explode? Because right after you remove, you've changed the size of the list. I is no longer meaningful with respect to that list. So this is really dangerous, bad thing to do. Whenever you remove from a list that you're iterating over, badness occurs. And that's exactly why the iterator throws a concurrent modification exception. It's trying to cover you from bad issues. By letting you know now. It's basically saying, hey, bug, fix it now, rather than wait until the bug gets really bad. When you don't use iterators, there's nothing that checks you. So concurrent modifications exceptions are your friend. Don't think of them as some problem that needs to be solved. Think of them as there's already a problem and they're pointing it out. So anytime you remove from a list, think very carefully about, do I have to go update all of my iterating values? Is that causing a problem? How would I show the delay? Yeah, basically don't kill the Goomba as soon as you hit him with a fireball. this is what you would do at the end of the delay. So he would go up in flames, it would delay, and then when he's done burning, when there's nothing but ashes left and his soul is ready to go up to heaven, that's when you return true, and then it finally kills him. So let's show how to implement the delay. Let's add an int, what should I call this? Burn fuel left, or burn amount, something like that, and a Boolean I am hit. Okay. The idea is when the Goomba gets hit by a fireball, I'm going to set I am hit to true. This Boolean value is just a flag that goes up. It says, hey, when I'm hit. So whenever the collision is detected, this becomes set to true. Then in my update method, I will say, if I am hit, then burn amount plus plus. If burn amount is more than, how many frames should we burn for? 20? Don't put a semicolon there. Then return true. That means kill me now. And basically, this code says, hey, the Goomba's going to sit there and he's going to burn for 20 frames before he finally says, okay, remove me from the list. This game is too harsh for me. Time for me to be gone to a better place. And there you go. Now in my draw method, I will of course have something that looks like this, and it's going to say if I am hit, then g.draw image burn, else g.draw image Goomba. Something like that. The gist of it is, until the Goomba's hit, we don't draw the flames. Once he's burned for 20 frames, then we're going to bail out of the game. And of course, you should never have a magic number in your code. You should instead have something up here that says final int burn length equals 20. And then you should come down to here and change that 20 to be burn length, because that's more elegant code. Okay, does that all make sense? I was actually using an integer that counts the number of frames instead of time delays, yes. It's very common in a video game to count things in frames because we have this constant steady drumbeat of frames per second that's going on in the game. If you have one of those 3D games where the engine takes different amounts of time to draw the screen, and so it's just going to draw as fast as it can, and you want your game to move on at a steady rate, you might want to tie it to a clock rather than a frame count. I'm kind of suggesting frames are a good substitute for time in this case because we're doing a lightweight side scroller where it doesn't take that long to draw the whole screen. So I'm not worried about time and frames getting out of hand with each other. Have you ever played a video game where you're running along and suddenly lag occurs, there's too many bad guys on the screen, and the frame rate chops in half? It's because they tied everything to frame rate instead of to a clock, and their bad code's going to wait around for the next frame to occur before they increment their counters, causes all kinds of problems that are never supposed to occur. So yeah, it's a known issue. Probably better to tie everything to the wall clock if you want to have consistent behavior, but even then you'll get teleportation where things jump around after it freezes for a while. There's all kinds of issues that come up in video games, and if you understand it, then you're doing it right, I guess is the answer there. Okay, any other questions? Any help I can give you on the assignment? Do you feel confident you understand assignment 4? Inside of our view somewhere, we used to have this thing that said int first tube is equal to find first tube that's on the screen. And I passed in the scroll position, model dot camera post now, right? And this does some kind of a binary search which efficiently finds the first tube that's on the screen. And then our loop looked like this, equals first tube, I is less than I'll just say true, I++. And then in here we had a tube t equals model.tubes.getI. If t.x is more than the screen width, which is like 600, then break. And here we had the draw tube code. This is what you're talking about, right? Okay. First thing I want to clarify is, yeah, we did this in assignment 2 or something like that. You don't have to do it right now. If you want to just go draw all of the sprites, model.sprites.size I++, and forget about that, that'll work and we'll call it good. The reason that's somewhat efficient is, hey, this draw function, if it's off the screen, it's just going to return anyway. Now, to be clear, that's not entirely efficient because we're still iterating over them. With the old way, we didn't iterate over them. So this is not as efficient as it could or should be. This is kind of me just saying, hey, this is good enough for your assignments. So is your question, do you need to do this still? Or is the question, what if I want to do it? How would I do it? It's that one? Okay. So let's pretend that you say to yourself, that's cool that you're letting us get away with this, Dr. Gashler, but I want to write really, really good game code. How would I write a really awesome game engine? Shall we do that one? Okay. Well, here's a problem. I've stuck everything in this one array list called sprites. And there's a reason I've done that. It's because I'm trying to force you guys to use polymorphism. And I want you to use polymorphism because it's a powerful tool and it's important to understand for programming. Having said that, if I'm a hardcore gamer, the efficiency of my game becomes really important, and having elegant, clean, nice, organized code kind of not so important. So let's suppose now I don't care about using clean polymorphism, I care about efficiency. I'm going to have 2 lists of sprites. I'm going to have one called, let's go to my model. How about one called static sprites and one called moving sprites, or something like that? Does that make sense? In this case, static, I don't mean static as in Java static. I mean static as in not moving. And I'll say still sprites. Stationary? Stationary sprites. Okay. The point is, you have a lot of stuff like tubes that just sit there. Tubes don't usually move, except for that one level where they bounce up and down to the music. But we're not on that level. If I had 2 lists, I could easily sort this one. And this one I would have to update very carefully. So then I would write my code such that the vast majority of the things in my game are in this stationary list because I'll keep it sorted and I'll draw it really fast. So down here, I'll have stationary sprites. I'll have 2 blocks, one that draws all the stationary sprites. Then I'll have some code that draws the moving sprites, something like that. And now for the stationary one, I can do this thing where I say find first one on the screen. And of course, it's not going to be tied to tubes anymore. It's going to be find the first sprite that's on the screen. And I'm going to break as soon as I'm done with them. If S, pretend that T is now an S, and this is sprites. If S.x is more than screen.width, then break. Now, this list is going to be drawn as efficiently as I possibly can, right? Because I'm going to use binary search to find the starting point, which is pretty fast. Now, I could probably even skip binary search if I added a member variable that kept track of where it was last time. And I could just basically keep sliding it over by 1 every time something scrolls over. So even binary search probably isn't fast enough for me. I could do better. Then I'm going to draw this really fast. This moving sprites list, I'm going to keep as small as I possibly can. Why? Because anything moving, I'm going to have to update every time because it's too expensive to keep sorting this list. You see that, right? Sorting is a rather expensive operation. I just don't want to do it. Alternatively, I could use some kind of auto sorting thing where the sprites start swapping places with each other in their list when they recognize they've moved. All kinds of tricks can be played to try and keep it efficient, but I think this is probably a good enough solution. That is, if I have two lists, now I can throw my Marios and my Fireballs inside of this moving sprites list, and I can leave everything else not moving. Did you ever notice when you play Mario that the turtles that are way, way, way down at the far end of the model, meaning if you had a turtle way down here, did you know they don't actually sit there and move back and forth between two tubes until you get there? They actually, yeah, there is no Santa Claus either. And when the view finally rolls all the way to the right and you finally get near the turtle, then the turtle suddenly gets activated and it actually starts walking. Isn't that disappointing? You just wish that the whole model was constantly going. But the thing is that would just be taxing the machine to update things that you can't actually see. Even the Hammer Bros, they just sit there. They take a nap until you get close, and then once you're close enough, they start throwing their hammers. And there's some optimization. Now, I don't actually know this, I'm making it up, but I do know it. No sane programmer would write a video game where the entire model is constantly going. That would be a whole lot of computation to update a world that you don't have to keep updated. Everything that's within some range of the view is going to be active, and that way as soon as Mario gets to it, it looks like it's doing its job and everything's happy. And so they probably have something like this where they have a set of moving sprites and a set of stationary sprites, and that way they can do things more efficiently, and that's about how you do it. Now, I don't know if that's the complete answer. This is not the solution to all video games. This is approximately how I would approach this game. And the first thing I'd do after I wrote it is I'd test it, and when it didn't behave the way I wanted it to, I'd tweak it up. And by the time I was done, it would probably look nothing like this, because code should evolve. It should keep on morphing, and the more problems you solve, the more your stuff's going to move around and change data structures and et cetera.